Welcome back to the channel. So the last time we tried doing some soldering on some of these pieces, and things just wasn't working out. So after doing some research and looking into it a little bit more and getting some good feedback from the viewers, we've got a whole new plan this time. So I think we've got a solution that'll work and get everything fixed, and we can continue moving forward. Okay, so the first thing is tried soldering this piece of tungsten, this TIG electrode, to this piece of drill rod, and that wasn't working. So after consulting my expert, ChatGPT, kiddingly, but it is a good resource to use. You have to take it with a grain of salt, but you can get some good ideas. So it agreed that it is possible but extremely difficult to solder of any kind, silver solder or plumber solder, anything, to tungsten. It's hard to get it to wet out onto the tungsten, and I would agree with that. So it did say that, however, many model engineers do use tungsten TIG electrodes for points, but to use it, they normally either press it into the piece of metal, make it a press fit, or put it into there and paint it or stake around it somehow, some sort of mechanical contact in order to hold it in. So I think that will work in this situation. There was another viewer who asked about brazing it, but I think you would have the same problem with the braze, with a brazing rod, even getting it to try to wet out onto there. So my plan is to put the new electrode back in the lathe, use the Dremel and the grinder, a grinder wheel on it as a makeshift tool post grinder, and I'm going to go ahead and drill this hole all the way through where we were trying to solder this onto there earlier. I may go to look to a little bit bigger size, and then we are going to grind the electrode down and make it a press fit into this drill rod. So we'll drill this hole through, and then we'll grind this down smaller, and then we'll press it into there. And then we might just put a little dab of retaining compound on there just to hold it in. There's no force trying to necessarily pull it out, so we just need it to stay in there and not fall out. So we're going to make that a press fit, and that should fix that issue. There was also question, well, the next issue was soldering this hacksaw blade onto here. And first things first, I thought about it the same, and then I had a viewer comment back that he had built a couple of these engines several years back, and he didn't remember soldering that hacksaw blade into there. And I had the same thoughts early on. I couldn't figure out why the hacksaw blade needed to be soldered into this bracket, because it's going to be bolted through here, and it's going to be bolted on to this arm. So the bolts will hold it on. And after looking back at the plans, one of the arrows that was going to the silver solder that I thought was to silver solder this hacksaw blade into the back of this bracket is actually going to this, where this drill rod gets silver soldered onto here, which does need to get soldered on. So we're not going to solder the hacksaw blade to this. I'll make a new hacksaw blade piece and drill the two holes in it, and then it'll just bolt on, which is good because it does need to be adjusted some for this latch, governor latch lever that goes to here to set the gap. So we will need to take it off and grind a little bit off on the end there to set our gap. So that'll fix that problem, and then there should be no issue soldering this drill rod to the piece of steel here. So press fit the electrode, solder this, and then bolt the hacksaw blade on, and that should get us back in business. But there was some questions about the soldering, so I'll go over a little bit of that. And I'm by no means an expert at this. I'm always willing to learn. So there was a question about what kind of solder that I was using, and this is a Harris product. It's called Stay Bright, and it comes in a kit with some flux and the solder. And this is a liquid, it is a liquid flux. So this is not a high content silver solder, and I did know that going into it. It's, if you get up into like the 45, 55, 65% silver, those are extremely expensive. They're $50 to $100 for a roll of solder. So this stuff is a low silver content. It's about 6% silver, so it is pretty low, but it is a silver bearing solder, which for what I'm doing, I don't really need the strength of a full silver solder. I honestly could probably get away with just some plumber solder, but I like this stuff for the small size. For the small type stuff that I'm soldering, I have some plumber solder, but it's a much bigger diameter, so I just like to use this stuff here. And it melts at about 425 degrees Fahrenheit or 218 degrees Celsius. So that did lead to a question of, well, how hot was I getting things when I was using the propane and oxygen acetylene together? So I was curious to look up some temperatures. So a propane by itself burns at about 3,600 degrees Fahrenheit or 2,000 degrees Celsius. The MAP gas, the old version that was true MAP gas, burns at about 5,720 degrees Fahrenheit or 3,150 degrees Celsius. That was discontinued in about 2008, so it's hard to find those cylinders. I used to have one, but I did check, and the one that I have that I've been using is the new version, which is my MAP Pro, so it's a mix of MAP gas and propane. And it burns a little bit, or burns a little bit hotter than propane, but quite a bit cooler than what the old MAP gas did. So it's about 3,800 degrees Fahrenheit or 2,100 degrees Celsius. So if you mix that, either of those with oxygen, they're going to definitely burn hotter. So what I had set up the first time was a propane oxy setup, and that almost doubles the temperature. It's 4,600 degrees Fahrenheit or 2,550 degrees Celsius. And just for comparison, MAP gas with oxygen, a MAP oxy setup is about 5,400 degrees Fahrenheit or 3,000 degrees Celsius. And then oxyacetylene, which I don't have, but that is about 6,000 degrees Fahrenheit or 3,300 degrees Celsius. So MAP gas, MAP oxy is just a little bit less than what oxyacetylene temperature is, and then the propane oxy is not much less than that, so it is pretty hot. So that's way too hot. I don't need to do that. I think I'm just going to go back to just pure propane. That burns at about, like say, 3,600 degrees Fahrenheit, and then this particular solder will melt at about 425. There was another viewer that said when he first started silver soldering parts, that part of his problem was heating the parts too fast, which I think is also an issue that we had here with the extremely hot temperature and the small parts. It just got the parts too hot too fast, which also did not allow the flux to work properly. So it did oxidize the hacksaw blade, which meant that we were doomed from the start, that was never going to do a good job. So the flux just wasn't allowed to do its job. There was another viewer that said that Dave, that he recommended that there is a paste version of this that works a lot better. So I'll get some of that on order, and we'll try that on some future, because we still got a lot of soldering to do on this project, especially on the carburetor section down here. There's quite a bit, so I'll get some of that paste and give that a try. He said that it worked better. Dave's also the same one that said that he did not solder the hacksaw blade to this, that he just bolted it on. So I think I know what the issues was, and then we can get some soldering done here. We'll try it again with just some propane on these two parts, and some flux, and then, like I say, I'll get some of that paste for the future. So we're going to turn down this electrode, turn down a new piece, press fit into here, cut a new hacksaw blade, this bolts onto here, solder this to here. Then we can get this finally mounted, transfer the holes and get those drilled and tapped into here and get that finished up. And then go back to our bracket here. We still need to drill a couple of holes here that are mounting holes, and then a couple of holes from the bottom here that get tapped to bolt this block onto here. And then there's a cross hole that gets bored into here, and then it actually gets counterbored from the back because there is a spring that goes inside of here. And then I will cut another piece of drill rod that will go into here that gets threaded on the back with 2 nuts that holds it, and then it gets a point electrode on the end there. So I'm going to turn down 2 of these when I do this, and then we'll do the same thing. We'll just press fit it into the end of the piece of drill rod, put the spring in there and the 2 nuts, and that should complete our points. So we'll get started on this and see what we can come up with. Oh, and if all else fails, I do have an old set of points here that the spring must have got hot in. It lost all of its tension. They should be closed here. This is out of one of my Cub Cadets. So if all else fails, we will grind the back off of these right here, and we'll pull this points section out of these, and then we'll use that to go onto there, which I'm pretty sure that I can solder because that's what I used on the Upshur vertical single engine, was a set of points like this. This is steel back here. There's a little bit of steel on the end of it, so if we grind this off, we can actually solder to this steel, but hopefully we won't have to do that. Okay, so a lot happened there. So I finished up this bracket, went ahead and drilled the 2 holes in here where it mounts onto the casting, and then drilled and tapped the 2 holes to finish mounting this block to the bracket. And then this block is counterbored. It's bored all the way through 1/8 of an inch, and then it's counterbored down to about right here, 3/16. And then I made this piece out of some 3/16 drill rod. So I turned this down to the dimensions to 1/8 of an inch, and then threaded it for 540. Then I took an 1/8 inch end mill and made a little pocket in the end here where I could install the points, the piece of tungsten TIG rod that I cut off earlier. I actually put a little dab of super glue in there just to hold that in there, so it's good and tight. And then there's a spring that goes on to here, and this gets installed in here. So you can see that there's a plunger action, and you had to do a little bit of filing and fitting to get this to where it would work good and not bind up. So then the nuts go on the back side, and I'm pretty sure that this is how you adjust the timing and then also the gap on the points. So we won't adjust any of this. This won't be final until we get the cam made and I know how far where the points is going to be at. And then there will be a wire that'll attach here between these two nuts. So that goes together like that. Then I remade this piece, got the two holes drilled in there. Then I turned down a piece of the TIG rod and then drilled this hole, went ahead and drilled this hole out. I actually had to remake this piece because it is drill rod, and once you heat a drill rod and then cool it, it gets hard. So the hole that I had in there initially was so hard that I couldn't drill through it. So I actually made a new piece, drilled a hole through it, and then ground down the piece of tungsten so that it would fit into that hole. You can see the little pip mark there where I cut it off. So that is good and secure in there. And then I resoldered that piece to our bracket. So we'll go ahead and mount this on here and I'll show you how it all goes together. If I can get all the holes lined up. So this piece is going to mount on here. Like this. See if I can get the screws started. Got a lot of stuff to line up here. Okay, that one started. Let's see if we can get the other one in. And again, I did not solder, and that was just a mistake. Thinking that that needed to be soldered, that piece does not get soldered to the back there, just gets bolted through, and that holds everything on. So you can see now how that piece mounts on there. And then again, our governor catch lever will catch the end of this right here. And then I don't know if this spring is right. It was a spring that I had that I decided to try, and we may need to adjust it later. There are dimensions in the plans for what this spring's supposed to be, and this spring was pretty close to what those dimensions was. So we'll try it and we'll adjust it later if we need to. I'm not real sure where exactly this arm is going to be at. So we'll figure that out once we get the cam on there, and then we'll adjust this spring if we need to. And then this will eventually mount to here, and then that is what makes the points. But there again, I don't know exactly where this is going to be at. Back and forth, so I want to wait because there's no dimensions really in the plans of where to mount this bracket other than it mounts to the side here. I do need to trim the bracket out just a little bit. It's hitting this boss right here. Once we get the cam in there and I kind of know where the points are gonna live at, then we can get this piece adjusted and get it mounted. But I think that puts us back on track. That pretty much finishes up the point system, other than eventually getting this mounted here, and I think that's gonna work good. So that's going to do it for this episode. Thanks for watching.